Hi everyone, this is Cyrus from AML and my topic is framework for interaction between database and microservice architecture. Introduction. Migrating from monolithic applications to microservice architecture brings about a number of challenges. Splitting and sharing database among microservices is a case in point. In this framework for managing the splitting of database among microservices, the proposed solution maintains data consistency and independent deployment of microservices while enhancing the solution to latency problems. The evaluation results shows the enhancement in performance as a result of using the proposed framework. Flexibility is a key design requirement for business software. The microservices architecture is a way of building flexible software by independently developing and deploying small scale software components that can be integrated. Applying the concepts of independent deployment makes it possible to changes or replace individual services without disrupting the whole system. While the idea of microservices bring about a number of benefits in terms of flexibility, however, handling database within a system of microservices is a challenge issues in a typical monolith application. The database is usually separated from the application process according to the MVC model. In a system where data is distributed among services, data consistency has to be handled. Any solution should not affect response time negatively. This is especially important in data-driven web application that deals with large size of data. There is a need for an efficient and coherent solution for managing databases in microservices context. Several approaches has been proposed for dealing with this issue. One approach suggests keeping the data stored in one database and managing services interaction with the monolithic database. Having a database for services is another way to deal with data in microservices architecture. The article presents a framework for managing database interactions in microservices architecture. Managing database for microservices architecture allows each microservices to control its own data according to its functionality and share data from database associated with other services. The main contribution of the framework is facilitating database transaction with microservices without the need for a central node. The transaction is performed by a message transferred between any two collaborating microservices. The proposed framework was compared with another solution in the literature, especially Synapse framework. The experimental results proved that MDMA achieved all the required functionality for splitting database over different services without the need for a central node. Moreover, MDMA showed smaller response time and smaller size of message transfer when compared with other solution. Problem definition and approaches for solution. Problem definition is after splitting a monolithic application into smaller services, the resulting microservices need a mechanism to manage the interaction of each individual services with its data. Implementing business transactions usually involves implementing queries that joins data related to different services. A key joint in the microservices paradigm in the concepts of independent deployment. Hence, traditional approaches that solve data consistencies are not applicable in microservices. For instance, non-stop structured query language manages data which are distributed over several connected machines. However, it requires all data to be set out structural queries language type, and all the databases should be deployed before running non-stop structured query language. Proposed framework MDMA. The proposed solution split complex large database associated within a monolithic applications into smaller simple databases corresponding to it, the business boundaries of each microservices. Advantages of the proposed solution. The main advantages of this work over the solution reported in the literatures are as follows: allowing each services to interact with the data associated with its functionality while maintaining the spirit of microservices. For independent deployment, each services is deployed with its database separately without any dependency on other services. However, after deployment, a services publishes the information that allows any other services to interact with its database, enabling cross interaction between a microservices and database associated with other microservices while maintaining efficiency and data consistency. The proposed solution support microservices interaction with multiple database, avoiding the dependence on a central API gateway. This leads to more efficient execution because the interaction requests are not gathered to a central node. Solution design and implementation. The proposed solution describes each microservice as a set of input ports and a set of output ports. The input ports describe the functionality that the services is ready to offer input request as well as its communication schema. The output ports list the required external database sent as output from the services to other services. Service deployment. So each service is deployed with its associated database in an independent manner. After deployment, the service checks the presence of other services and broadcast the following information: name of the services and its location, user transport protocol, user data protocol, and the services interface and the available fields to share and how to access it. Then the services discover services information to find out the services that matches its output ports and broadcast. Conclusion. This framework has a solution for data consistency and transaction latency problems in microservices environment. We presented a framework for managing the splitting of database among different microservices. Evaluation results. The framework has been evaluated against an increasing number of requests. The evaluation results shows enhancing in both responsive time and total number of messages as a result of using the proposed framework. We believe that using the proposed solution, it is possible to build services with better database independence. Thank you.